If alpha and beta are the roots of equations, so you look at this question and you ask yourself, how is it part of binomial? So I just want to like show you how you can use binomial to expand expressions like this one and that one. Of course, I'll try to approach the first two without binomial, and then I'll try to show you the necessity of using binomial expressions, expansions. Alright, so given alpha and beta the roots of the equation 3x squared um, plus 5x and then plus 4 equal to 0. Given that's the case there, we are supposed to determine the given expression. So alpha and beta can be expressed in terms of the product, which is c over a, and then the summation, which is negative b over a. So you notice that the form of the quadratic function is actually ax squared plus bx plus c. So if you look at the given equation, which one is c? C is 4, right? So the product becomes 4, our a is 3, alpha plus beta, negative b, negative 5 over 3. So this is basically what we have. Before I forget, so the product, take note of the product of the beta is 4 over 3. The sum is negative 5 over 3. So we can go on and erase this. At this point, feel free to pause the video and try out the questions now. So the basic idea is you're supposed to express the given questions in the form of either the product or the summation or both. So if you look at the first one is a very common question: alpha squared plus beta squared. So there's no way you can actually substitute in that directory. So you're supposed to find the other form of the question that can help you. Alright? So let's try to see how we can do that. So we know that the shortest way we can try to think of this is we know that there is a term that can be alpha plus beta squared, and if you expand this quadratic, it gives you understand that this means alpha plus beta multiplied by alpha plus beta. So if you actually want, you can actually use binomial even from just the start to expand this. But of course, you know that you can multiply alpha with the entire part there, it becomes alpha squared plus alpha beta. Again, if you get the beta times alpha, it will also be alpha beta. That's why this term becomes 2, comes out twice. So it becomes a 2 there, 2 alpha beta, and then of course for the third part, it is just beta squared. Cool, right? Now, what if you try to think of binomial expansions? Think of a Pascal triangle that we've looked at already. You can see that the first term is 1, 1, and then for the second expansion, it's 1 to 1. So you can see that's where these are coming from, right? So coefficient of a 1, coefficient of a 2, and coefficient of a 1. So you can equally use that for the expansion. Okay. Now you would wonder how. So if I know that 1, 2, and 1 are my expansions, or are my coefficients of expansion, so for the first term I can start with alpha, and it can start with a maximum power, which of course will be alpha squared, and then the other one will start from 0, so it will just not exist or show up there, because beta to the power 0 is just 1. And then for the second part, alpha will now reduce by 1, beta will now increase by 1, it will be beta 1. And then for the last one, the 1 I can just remove it, doesn't make any difference, of course. And then I know that at this point, since alpha has been reducing, it will be alpha to the power 0, so no need of showing it, and beta will now be beta to the power 2. Of course, if you reduce this, it becomes alpha squared plus 2 alpha beta plus beta squared. So this is the role that the binomial expansions are playing in this question. Okay. But for alpha plus beta to the power 2, which is of course easy for you to look at, you can easily multiply even without binomial. But of course, you will see the necessity as we proceed. Now, how do we actually answer this? Remember, our focus is we are trying to find the value of this part. Okay. So the question I can ask you right now is, can you see it on the right hand side? So we can. So we can actually group this one and that part. So alpha squared plus beta squared. Now this part is not. So we can take it on the other side, or rather add the additive inverse on both ends. So where we have alpha plus beta squared on the left hand side minus 2 alpha beta. So this one has been removed from the right hand side. So what has become the subject of the formula is actually the expression that we want to simplify, or actually evaluate the exact value of it. So we can now see that the formula we've come up with is alpha plus beta in brackets squared, and then we're subtracting the middle term. So at this point, we now know that the question that they're interested in us looking at, we've expressed it in terms of the product of alpha and beta, and then also as a summation. So we can equally we can actually simplify it very fast from this point, since we know both the product and the sum. So we can start with the summation, which is negative 5 over 3 in the brackets, raise the power 2, minus 2 alpha beta, the product is 4 over 3. So negative 5 over 3 squared will give us 25 over 9. And then 4 times 2 is 8 over 3. At that point, you can still go on and actually simplify. Common denominator is a 9. And then you have 25. 3 into 9 is 3 times 8, 24. So 24. So with a 24, we have 25 minus 24. You end up with a 1 over 9. So that's for the first one. We're done. For the video, and try out the next one. So every time you want to find the exact value, what you want to do is express whatever you're given in the form of the product and also the summation. So for the second one, we have alpha over beta plus beta over alpha. So I don't know how, but let's just try to add these. Common denominator is what? What's the common denominator? So common denominator is alpha beta, and then if we try to divide by beta, which is the first one, you're going to remain with alpha multiplied by what's on the top. It will be alpha squared. Again, if you go to that part, it will be beta 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 squared. So adequate, you can see that okay, this is actually it's related to the previous question that we had, right? So what do you think? What can be done at this point? So check the numerator. The numerator is basically what we had in the first part. So we actually express that in the form of alpha beta bracket squared minus 2 alpha beta divided by alpha beta. So at this point, the entire expression has been expressed in the form of the addition and the product of alpha and beta. So we can just substitute alpha beta squared, alpha plus beta, that's what? Negative 5 over 3, let's not forget. negative 5 over 3 squared minus 2 alpha beta. The product is 4 over 3 divided by alpha beta. Alpha beta is 4 over 3. So dividing by that, okay, can now try to simplify this. So obviously on top we understand that what we found for whatever was on top, we found 1 over 9 if you're paying attention, because this is basically the same. For the sake of this question, it's basically the same. So you just want to get the same 1 over 9. If it's not given in the previous question, this is where now you just have to manually simplify this. But since we know that we got 1 over 9, we won't take time. 1 over 9 divided by 4 over 3 is as good as, so if you're dividing by 4 over 3, that's as good as multiplying by the reciprocal. I'm teaching you certain shortcuts that will not waste your time. So 1 over 9 multiplied by 4 over 3 is equal to the previous step. So 4 over, is it really 4? We're dividing by 4 over 3, yeah, and then multiply by the reciprocal. Wait. If the reciprocal 4 over 3 is 3 over 4. So 3 there it's 1, 3 there it's like 3. So we have 1 over like a 12. So that's it for the second part of the question. We are now at liberty of proceeding to the next one. So before you pause the video, I want you to use binomial expansions instead of using the normal expansions. I want you to use the binomial expansions to simplify that. So obviously you've gotten an idea in a case where you have alpha squared plus beta squared. We said the suggestion there was to express it, or get to express it in the form of alpha plus beta in brackets squared. Okay, so what you basically get to do is expand this part and then try to identify the existence of that expression in the expansion. Remember, it was alpha squared plus 2 alpha beta, 2 alpha beta, and then plus beta squared. So we identify that, oh, okay, we have it there. It is alpha squared plus beta squared. And then the term that we are not interested in can go the other side, so that we can come up with a subject of a formula. So it was actually alpha plus beta squared minus 2 alpha beta. So equally, we can actually do the same for this one. So you can now pause the video and try it out. But of course, we don't want that kind of, I want you to, as you think of expansion of alpha cubed plus beta cubed, so as you think of how you can go about that, just group it in the brackets and then raise it to the third power. So now as you think of expansion of this, I want you to use binomial expansions. You can use the Pascal's triangle, the binomial theorem, whatever you use at this point. No restriction. Okay, so what should I use? Okay, let me use the Pascal's triangle of the binomial theorem, whatever. So we have 1, 1, 1. Let me use the Pascal's triangle. For the next one, I'll use the binomial theorem. So 1, 2, 1, 1, 3, 3. I've already shown you in the previous question how you basically get to come up with this triangle. So where we are seeing the 3, this is now the third expansion. We start from this one. The first one is not an expansion. So the first one, second, and third. So these are the coefficients we're interested in: 1, 3, 3, and 1. Okay. Now we'll start with alpha to actually get the maximum power. Right. So it will be alpha to the power 3. The next coefficient is a 3. Alpha will now reduced by 1 to be to the power 2. So beta will now start from 1. So one thing that you're not seeing is from the initial step there, I believe by now you understand that the coefficient there was a 1. alpha was the maximum power, beta was from the minimum power, so that's why it's not showing. So on the next step, we expect that beta will actually increase by 1, alpha will reduce by 1, and then we're following the first Pascal triangle to help us with the coefficients. Okay, and then we've got 3 again. Alpha will now reduce again, it will be alpha. Beta will now increase, it will now be 2. And then we have the last part, which is of course going to be just beta to the power 3, since alpha is going to be the power 0 at that point. Remember in the previous step, it's like I want to clearly show that that 2 is actually the power of beta at that point. So we expanded there using the Pascal's triangle. Now we have to actually identify the existence of alpha cubed and beta cubed. We can clearly see them there. So if we group them, we have alpha cubed plus beta cubed. Okay, so what we'll see is we are remaining with alpha plus beta, the power 3 in the brackets. So if this term goes the other side, it becomes minus 3 alpha beta, of course alpha squared, and then also minus 3 alpha beta squared equal to that. Now don't forget that these are two different terms, they are not the same. So you can actually try to factorize 1 alpha plus beta to the power 3. We can factor out 3, and then I can also see alpha is common, so is beta. For the first part, if you remove negative 3, alpha and beta, since alpha is squared, alpha will remain. And then for the next part, of course, remember if you're dividing by negative, it will become positive. 3 alpha, since beta is squared, beta will still stand out. So we've now made our interest to be the subject of the formula. We're interested in alpha cubed plus beta cubed. And if you try to check everything on the left hand side, that is the summation, that is the product, that is the summation. So we're able to simplify it. Okay? How do you do that now? Just substitute. Just substitute. So alpha beta, value there is negative 5 over 3, the power 3, minus 3 alpha beta, which is like the product, 4 over 3, and then in the brackets we have alpha plus beta, which is again negative 5 over 3. That's what we have, and we believe that is equal to our question of interest, alpha cubed plus beta cubed, trying to determine the exact value. So this is now just dependent on your simplification, how you can actually go about simplifying this. So 5 times 5 is 25 times 5, that's going to be negative 125. 3 times 3 is 9 times 3, 27. That can just divide. You remain with a minus 4. Minus 4 times minus 5, that's a minus 20 over 3. If I'm not mistaken, that should be a minus. How is it a minus? Where? This is a negative, that's a negative, so it's a positive 20 over 3. Okay, I think this is something easy to simplify at this point. Common denominator is 27. That remains 125. 3 into 27 is 9. 9 times 20. 9 times 20. 9 times 0 is 0. 9 times 2 is 18. So 180. Now 180 minus 25 should be 55 over 27. So that's where you end for the third part of the question. Let's try to proceed. Now I said for the last one I'll use the binomial theorem. So I want you to try it out. So we have alpha to the power 4 plus beta to the power 4. I want to express it in the form of the product and also a summation. How do we go about it? Don't think too much, try it out. Give it a shot. What have I written there? That's beta to the power 4, not alpha. So basically what happens here is it's something very simple and straightforward. So you know your binomial theorem. You understand that if you've got alpha or a plus x raised to the power n, the expansion becomes a to the power n plus, and then you have n a to the power n x plus n choose 2 a n. You now, this is n minus 1, of course, so that's n minus 2. That becomes x squared. You continue like that, and so on and so forth. So basically, you are applying the same idea that we've applied previously. Okay. Where you understand that one starts with a maximum power, the other one starts with a minimum power, right? So if we're going to put this in the brackets, alpha plus beta to the power 4, we understand that the first expression, we can choose to start with alpha, so we'll have alpha the maximum power, and then we'll be using now the binomial to come up with the coefficients. Everything else remains the same. So forget about the formula. The shortcut is combinations, right? So you start with, for the first expression is n0, second one it's n1, so you just be increasing the values down. So the Pascal's triangle is helping us to come up with these coefficients, but we can use combinations to just help us come up with the coefficients. Okay, and then apply with other rules, the other parts. So n choose 0, in other terms, this is just going to vary to 1, this is just going to vary to n, and that's why for the first two we're able to tell 1 and n. Okay, so 1 and n are the first coefficients, and then we can proceed from n choose 2, n choose 3, and so on and so forth. Just take note of that. So for the first one, 1 makes no difference, so alpha with the maximum power, beta with the minimal power. Second is n, which is the power itself, 4. Okay, what do we know there? So it will be 4 times alpha will now reduce by 1, it will be to the power 3. Beta will now increase by 1, it will be the power 1. The next coefficient is we don't know. So after 1 plus n, it's now n choose 2. What does that mean? It means where there is n now, in this case, our value is a 4. So let me just show it to say the next coefficient we have is 4 choose 2, 4 choose 3, and then 4 choose 4. So 4 choose 2 means, I'm trying to assume calculators are not allowed. So 4 factorial, 4 minus 2 factorial, 2 factorial. So whatever you have on top, which is the value of n, is should be 4 factorial, and then subtracted 2, which is this part, factorial of the subtract of the difference, and then of course 2 factorial. So 4 factorial will just remain to be 4 times 3 times 2 factorial. So we have 2 times 1 and then 2 factorial. So that can disappear. 2 into 4 is like 2, right? Times 3 is 6. So we have a 6. Alpha will now reduce by 1 again. beta will increase by 1. So we continue like that. 4 choose 3. 4 choose 3 is what? 4 factorial. 4 minus 3 will just be 1 factorial, and then 3 factorial. So on top we're just going to remain with the 4. So 4, and then alpha will reduce again, and then beta will increase again. Finally, we can guess the last one will give us a 1. Okay, so that would be alpha at the power 0, which we don't have to show. Beta will now be the maximum power, which is, how have we done it? So I've not done a good job. So here it was the power 1, there it was the power 2, here the power 3, and now the power 4. Okay, that's fine. Hopefully I haven't confused you using the binomial theorem, but basically the idea is, what we're trying to say is, just use the binomial theorem in the normal way. So you start with, like, in this case we've got a power 4, so it will be 4 0, and then alpha at the maximum power, beta to the minimal power. So you continue expanding like that. This is basically the main idea there. Alpha will be reducing, beta will be increasing, until you get to the last part. So assuming you've gotten that part and you've understood how to go about everything, so at this point now let's just like conclude by making that the subject. So if you try to observe, where are they? So that is alpha to the power 4, beta to the power 4. Everything else can be on the left. So we have alpha plus beta to the power 4. So I'll be subtracting everything else. Let's try to identify them. This part, 4 alpha cubed beta minus 6 alpha squared beta squared, and then minus 4 alpha beta cubed. So I've removed all the other 3 terms, and then everything else remains on there as our interest, which is of course this part. So this is now equal to that. So how do you go about it now, simplifying? So simplifying at this point will just require you to just like substitute into the given parts. But of course we want to be sure, is this already in the form of just a product and summation, or we've got some differences? What do you think? So the first part is already expressed as the sum. This part can equally be expressed as, you can group the two, just the same power 2, and then you can separate the others. But of course we can still go on and combine these 3. We've got a common factor. So I think 4, 6, and 4 can have a common factor of like a 2. So you can say alpha plus beta to the power 4. If we pull out a minus 2, I can see alpha is common, or I can decide to do something different and unique, but let me just go by the same way. So group out a 2, and then I can see alpha is common, and then I can see beta is also equally common. So what is limiting my highest power I'm picking? Beta there is only 1, there alpha is also just 1. So that's why I'm restricted. So if I want, I can ignore this part. Let's ignore it and only focus on these 2. So if we do that, that would imply we're going to have a minus 4 instead, factored out, and then alpha and beta. So for the first part, since it's alpha cubed, if we remove a single alpha, it will remain with a positive alpha 2. Then for the last part, we'll remain with beta squared. Okay. and then minus the 6 alpha beta, which can just be grouped together in brackets, and then raise the power 2. At this point we are sure of what we can do, but you can see there's something interesting there. To simplify that, remember it's alpha beta squared minus 2 alpha beta. So just plug in the values here. Alpha beta is negative 5 over 3, the power 4, and then alpha by beta is 4 over 3. For the brackets, alpha plus beta, again it's negative 5 over 3 squared, so I can just put that in brackets, and then minus 2 alpha beta, which is like 4 over 3. Okay, and then minus the last part, 6 alpha beta. So lot of space here, so minus 6 alpha beta, which is like 4 over 3. Now it is squared. So just simplify this and see what it gives you. Let's have the answer commented. So my area of interest was just trying to use binomial expansion to expand that, not really to find the value. So you can find the value by just performing simple manipulations of the values. Okay, hopefully my calculations on my paper are right. Should get something closer to negative 1501 over 108. Okay, so this is where we end for question 8.